So welcome back to the second session of module 5, what we are previously discussing about. So in this session, we are going to discuss something related to volcanic eruptions, landslides. So what are the different causes of landslides and its remedial measures? How best we can take remedial measures for the landslides and stability assessment for the soil and rock slopes. So that we are going to discuss in this particular session. So, what is meant by an volcanic eruption? It's an outpour of the ash and its earth or the magma erupts out. Generally, you must know what is meant by magma and lava. When it is inside the earth, in between the magma chamber, that is what we call it as a magma. When it comes out, that is we are going to call it that as a lava. Okay. So the mixture of melted rocks and dissolved gases which are accumulated below the earth crust is called as a magma, whereas the magma material which pours out of the surface through volcanic eruptions in the weak zones, wherever the cracks are available, wherever the weak spots are available, in that particular junction it is going to come out of the inside the earth and comes out to the surface of the earth. That is what we call it as a lava. So in an average, one volcano erupts in every 12 hours, and 1,500 volcanoes have been active in last 10,000 years. A violently erupting volcano that has produced ash fall, ash flows, volcanic mud flows like to be the same that will be there in all the volcanic eruptions. So, what might be the different causes of volcanic eruptions? So, plate tectonics, movement of plate tectonic plates, which is moving from one side to another side. So the plate causing the magma chamber to burst out. So this kind of eruption produces sticky, thick lava of temperature of 8,000 to 10,000 degrees centigrades. Point number two, the buoyancy of the magma. So the buoyancy, what is the buoyancy of the magma? That also plays an important role. The volume of overlying magma will increase due to increase in temperature, causing buoyancy. So this lighter overlying magma, when it rises towards the surface by virtue of the buoyancy and it erupts. Okay. The point number three, what we have to take it into consideration is the pressure from the gases of the magma. So that is contains of water, sulfur dioxide, and carbon dioxides, or the volatiles occurs in the magma with zero atmospheric pressure. So these increase their volume due to rise in the pressure conditions. So temperature and pressure conditions are the most important thing. So next point is forceful ejection. Forcefully it is coming out as a new magma into magma chamber will move up and erupts to the surface because of the temperature and pressure conditions which are exerted inside the magma chamber. Okay. So next one, what are the effects? What are the different portions of it? So tephra. So during the powerful explosion of the old lava at the top will burst into tiny pieces or small pieces if you're going to take small pieces. So those small pieces, so they will burst into air. So these are all, this will also cause some air pollutions. Leharas, so these are the mixture of water, rock, ash, sand, and mud that are originate from slopes of the volcanic occurs due to heavy rainfall. So because of the heavy rainfall, these are the leharas. Number three is landslides. Heat from the cooling magma can cause hydrothermal alterations of rocks, turning them into clay. So this weakens the rocks and increases the risk of slope failures. There is a more risk of there is a more possibility of slope failures. Flooding, explosive eruptions can change the surface areas around a volcano and disturb drainage patterns leading to a long-term flooding. So this flooding will also make some contribution towards the volcanic eruptions. Volcanic eruption will also impact on food. You know that water supply interruptions, homelessness, business forced to close, cost of the insurance climbs, unemployment, long-term issues which is related to tourism and all. So these are all the impacts of volcanic eruptions, and naturally we are also getting some pollution, natural pollution out of it. So let us move on to the next portion, that is what we call it as landslides. What is meant by a landslide? Landslide is a slow or sudden downhill movement of slope forming rock and soil material under the force of gravity. Okay, landslides are slope failures or natural erosional process. So this occurs on the hill slides, valley slopes, sea coast, river banks, and bends on the slopes of volcanic cones and the earth prone zones or prone areas, we can say that. So this will also have different portions of this or parts, we can say that. So typically it will having some crown portion means that is on the toppermost portion, we can say that. So this, if you are going to see the topmost portion over here, that is we can consider that as a crowny portion. So crown, the uppermost portion still in a place from which the solid rock or soil materials are turned away from the crest of the slopes. So we are at different parts of it. Okay. So next one is your strap. So the step fall of the undistributed material below the ground around the periphery of the slide material. So which is going to come down. So head, the upper part of the slide material, that is what we call it as a head portion, and slip plane, these share surface, the surface moment of the down slope hill towards the materials. We are having other portions of this flanks, transverse ridge, foot, toe, length, width, height, depth. So these are all the different portions of any landscapes which we are going to talk about. So let us move on to the different type of classifications of the landslides. Landslides are many types of broadly classified according to their characteristics parameters. Okay, so here slides, what you are going to see, that is slide, fall, flow, complex slides are also possible. Complex slides are also possible under this particular category what we are talking about. So under slides, we are going to have transitional or planar rock slides. Under that, another portion is rotational or slump or earth slide. So these are all the other portions which are coming under the that portions. Next one is flows. Under flows, we are having slow and fast. Fast means your rapid. We can also take it as rapid movement. Landslides in fast flows. From that, we are going to have slow and fast movement. Under that slow category, we are having soil creep and rock creeps. Okay, so we have categorized all these things into different portions of it. So you can see the figure in this figure. We are going to have soil creeps along the earth slopes, slumps, lahars, mud flows, and rock falls. We're going to have all these things. In this particular figure, also we are going to have rotational landslides, transitional landslides, block slides, rock fall. If you look at this particular figure D, you'll come to know. So these are all possible ways in the slides of highways, railway tracks, all those possibilities are that. D category is your rock fall. And E is your topple, T-O-P-P-L-E, topple, and F is your debris flow. Debris flows are also there. Debris avalanches are also there. Earth flow, you might have been seen in some of the cases. Earth flows are also there. Creeping, where the speed is somewhat lesser. Lateral spread is also possible. So these are all the different things what you're going to observe over particular slides. Mass failure is divided into four major categories. So each of them are subdivided into different categories. Let us see it over here. In flow edge, you are going to have slow flow edge, where you are going to have rock creep, rock soil creep, and solifluction. And in rapid, we are going to have earth flow and mud flow. In sliding category, we are having slump, rock slides, rock fall, debris slides, and debris fall. In subsidence, we are having sinking of masses. These are all coming under that particular category. You see the example of this pictorial representation of flow edge. Okay, next one is sliding. sliding from higher elevations to lower elevation because of the gravitational pull. Subsidence, subsidence, it's a normal area if it is going to move towards the a center portion which has moved down. That is what we call it as subsidence. Flow edge, it's a downward movement of the mass invariably. Okay. So next one is subsidence. Same thing. It is a sinking of the ground almost vertically downward direction, which may occur due to removal of the supporting nearby masses which are there. So what are the different causes of landslides if you're looking into that? Many factors that are causing for the mass of the material to slide or flow in a particular direction. Some of them may play a direct role and easily understood, whereas others are indirectly responsible for the instability of the land masses. All such factors that facilitates landsliding is one of the another generally grouped into two headings. So that are compared here is internal factors and external factors. If you are talking about the internal factors, the nature of the slope, what type of slope factors we are going to have in that particular section. Okay. Here, internal factors, what are the different type of internal factors? The great majority of the mass failure indicates that slopes are directly responsible. In almost in all the cases, the slope plays a very important role actually. Okay, in some cases, steep or very steep slopes are stable, but some other cases, even gentle slopes shown unstable conditions. So this is the one of the major factors if you're going to take it as internal factors. As far as water content, water act as a major thing as far as landslides are concerned. Water act as a number of ways, reducing the sharing of the strength of the rock or soil material, or the presence of water in the rock pores. That space affects the strength of the property, adversely affects that weakens the zone. It acting as a lubricating action in a greater extent. So water is very important factor. Water content plays an important role. So next point is composition and compaction of the mass. What the material is made up of. That is also very important thing. The composition which is made up of, composition plays a very vital role as far as stability of the masses are concerned. As far as sandstone, it exhibits a great variations in the chemical composition. Silicates, siliceous sandstones would be a greatly stable even during the intensive rain. So heavy rainfall, it is also plays an important role. So whereas clayey portion, if you are going to take it clay or calcareous materials, so suffers repeated failure under some conditions. Texture of the rocks also plays an important part, indicating the degree or packing of the grains. You know about porosity, permeability factors that really plays an important role as far as percolation of water through these masses. This is very important factors. So geological factors also plays an important role because of the dipping angle, dipping direction, weakened plains, fault zones, rock beds, presence of shear zones and weakness zones also plays an important role as far as geological factors are concerned. So these are all coming under the category of internal factors. When you coming to the external factors, rock mass failure occurs due to earthquake, blasting around the mines nearby. So these are all coming under the external factors. In that particular category, if you're going to talk soil creeping, this type of slow flowage of the soil takes place under the vegetation cover. Commonly, we can expect this in cloud humid slopes or frost condition. Okay, so particularly when the water seeping to the pores and expands due to freezing, so this repetition, expansion, contraction or drying out, wetting, so resulting in breaking of the soil to loose grains that can be moved downwards under the pressure of gravity. You know about this in all weathering factors, you are more familiar about these factors. Next one is solifluction. This is also a flow, this is slow flowage type under the particularly in mass movement, and this similar to soil creep in the rate of downward movement. This slow movement of blanket of soil or rock fragment occurs even a very gentle slopes often rainfall. So it's differ from the soil creeps into water content that is comparatively faster. Earth and mud flow, this is also saying this are the rapid type of clays, silts, moss movements takes place. So usually after the heavy rainfall, we can expect all these things. In mud flows, the quality of water, the quantity of the water is very high. Whole mass is reduced to a muddy, a slumpy type one. So under that conditions, we can expect external factors. These are all the external factors to be taken into consideration. Rock slides. It's a type of rock fail due to pull of gravity, which starts moving downwards without rolling action. The failure surface may be curved or planar in nature. It's a very complex phenomenon occur due to either natural or artificial frictions forces offered by these masses against the gravity. Rockfall, you know that this occurs when the slopes are extremely high. When we can expect the slope is also very important factor means when the slope is extremely high, rock surface are slightly fractured or jointed, so that falling occurs in so that large numeral masses which are there on the upper side that will fall. These block sides some distances and start pulling towards the down at a very steep slopes. So what are the remedial measures we are going to take care? So what are the different remedy measures that we can take care in avoiding these landslides? Many methods are controlling the slides are available to choice many of the methods. Some factors, nature of slide, the underlying cause for it, nature and amount of material involved in the economical conservation of such methods as the most important thing. Here, the existing slope is that, and you have to construct a retaining wall, and you have to maintain that level ground. Okay, providing what are the precautionary measures we are going to take here is providing adequate drainage. So this is most important thing. It involves removal of moisture content which is present in that particular soil or material what is there nearby. So grouting of these joints and other factors may prove helpful. Construction of retaining wall. All such devices likely to construction retaining walls are aimed to. So in order to avoid these things, we have to maintain adequate drainage pattern so that the water inside that should be removed out properly. As far as retaining walls are concerned, construction of retaining wall requires an accurate assessment of the forces which is going to fall on that particular structure what you are going to construct over that particular area. So here the retaining wall may prove exceptionally successful where the ground is neither too fine nor too plastic. So that you have to take care of all these points, very important. The sliding mass is likely to remain dry, it should be in dry condition. The movement of the movement of shallow nature. So it should be very small movement. Slope treatment is generally a good thing that we have to take care. So the material or soil which is under different conditions, the major reason is slope treatment. If you are going to treat the slope, if it is very deep, you have to reduce that. So if you are going to maintain the drainage patterns well and retaining walls well, and slope treatment is also very important. So in this particular session, we have learned about volcanic eruptions, different type of landslides and causes. What are the remedial measures we have to take care in order to avoid landslides? So after all, knowing all these things, we have to apply this knowledge to maintain this is applicable in civil engineering field where there is highways, railway track, railway tunnels, where there is a slope treatment is required. You have to avoid landslides under those conditions, and safety is very important. And you have to maintain the stability, and based on that, you have to make some construction. So these are all the points to be taken into consideration. This after knowing all these things, these are all the outcomes what we are expecting after these the points what we have learned. So next, what we are going to understand is some of the multiple choice questions. So you have to answer all these multiple choice questions. Mass movement. First one is soil reflection. An active volcano, so Mauna Loa, is located in which area? Hawaii, US, Brazil, Japan, none of these. Which of the following could trigger the landslides, lahar, tsunami, tidal waves, volcanic earthquake? Landslides are totally random events without identified triggers. So to answer all these, or to take care of this point, which is more suitable, you have to answer that. What do you call molten hot liquid rock while it is still below the earth's surface? Magma, igneous rock, cinders, lava. We already discussed about these points. When it is outside, what we call, and when it is inside, what we are going to call. When it is inside the magma chamber, we call it as dash. When it is outside the surface of the earth, we call it as dash. So that point to be answered. So after all these sessions, we'll wind up today's session in the session number 2, and we will continue the same in the next session. We'll meet in the next session. Thank you.